Tonight on Think Cosmos, we are doing what this channel does best. We are going to pull together the wildest, most important space stories that are breaking right now, in mid-November 2025. This episode is recorded for November 17th, 2025. The universe has been busy. We have a meteor storm's fast cousin lighting up the night sky. A brand new Mars mission riding on a giant reusable rocket. The first three-dimensional weather map of an alien planet. A rogue world behaving like a baby star. An interstellar comet screaming through our solar system from another sun. And fresh clues from the James Webb Space Telescope about the chemistry that might lead to life. So get comfortable. Well, let's spend the next 40 minutes together under a bigger sky. We start with something you can see with your own eyes. Right now, as this video goes live, Earth is plowing through a river of dust from a periodic comet called 55P Tempel-Tuttle. That river of dust is what we see as the Leonid meteor shower. If you step outside on the night of November 16th into the 17th, and again tonight on the 17th into the 18th, you may catch it near its peak. The Leonids are fast. They hit our atmosphere at around 70 kilometers per second. That is more than 250,000 kilometers per hour. Each meteor is tiny. Grain of sand, tiny. Sometimes even smaller. But the speed turns that dust grain into a streak of white fire that lasts a fraction of a second. Most years, the Leonids give you about 10 to 15 meteors per hour under dark skies. Some years, when Earth plows through a denser filament of dust, they can turn into a true storm. In 1833 and 1966, witnesses reported thousands of meteors per hour. The sky looked like it was falling. This year is not expected to be a storm. But conditions are still special. The moon is out of the way. Skies are forecast to be clear in big parts of Europe and the Middle East. Observers in places like Qatar and the UK are being told that this could be one of their best Leonid views in years. If you can, go outside after midnight. Find a dark place away from city lights. Look up toward the constellation Leo, but do not stare at one point. Just let your eyes wander. Give them 20 to 30 minutes to fully adapt to the dark. You are not just watching some pretty streaks. You are seeing the debris of a comet spread out along its orbit, burning up in the air of your own planet. Every meteor is a message, a piece of frozen dust that has been circling the sun for centuries, turned into light in less than a second. And while you are out there looking up, something else is on the move. Far above, new hardware is on its way to Mars. A few days ago at Cape Canaveral, a giant blue and white rocket called New Glenn lifted off on only its second mission. Riding on top of it were two small spacecraft with a big job. They are part of NASA's Escapade mission. That stands for Escape and Plasma Acceleration and Dynamics Explorers. Both spacecraft were built by Rocket Lab for NASA and the University of California, Berkeley. They have a simple nickname: Blue and Gold. Their target is Mars, not the surface, the space around it. Mars sits inside a stream of charged particles coming from the sun. The Martian atmosphere is thin, and the planet has only patchy magnetic protection. Over billions of years, the solar wind has stripped away a huge amount of that atmosphere. Escapade will send these twin probes into different orbits around Mars to watch that stripping process in detail. Think of them as two tiny weather stations, watching the invisible storm where Mars' upper atmosphere meets space. They will measure how particles are picked up, accelerated, and lost. Those measurements will feed into models that try to answer a big question. Just how fast did Mars lose its air? And could it ever hold on to more in the future? The launch itself was a milestone. New Glenn, the heavy lift rocket built by Blue Origin, flew its second mission and its first NASA planetary mission. It successfully lofted Escapade into the planned orbit. Then the enormous first stage flipped around, re-entered the atmosphere, and landed vertically on the company's ship, Jacqueline, in the Atlantic Ocean. A fully reusable booster, a new route to Mars science, and a sign that the next decade of exploration will not belong to just one rocket or one company. New Glenn joins Falcon 9, Falcon Heavy, and soon Starship as part of a growing fleet of reusable heavy lifters. The more they fly, the cheaper each kilogram to orbit becomes. And that opens the door to more science missions, like Escapade. Meanwhile, another rocket is on the pad, on the other side of the United States. From Vandenberg Space Force Base in California, a SpaceX Falcon 9 is scheduled to carry Sentinel-6B into orbit around the same date. November 17th, 2025. Sentinel-6B is an ocean-watching satellite. It will track the height of sea surfaces around the globe with centimeter-level precision. It is part of a long chain of missions that have watched sea level rise as Earth's climate warms. So in the same week, we have one mission leaving Earth to study the atmosphere of Mars, and another lifting off to monitor the changing oceans of Earth. Two sides of the same story. How planets keep, lose, and rearrange their air and water under the energy of their stars. Speaking of stars and air, we need to talk about what the James Webb Space Telescope just did to an exoplanet. For the first time ever, astronomers have used JWST to build a three-dimensional map of a planet's atmosphere. Not a planet in our solar system, a world 400 light-years away, called WSP-18b. WSP-18b is an ultra-hot Jupiter. It is 10 times the mass of Jupiter. It swings around its star in less than 24 hours. The same side of the planet always faces the star. One hemisphere is in eternal day. The other is locked in permanent night. On the day side, temperatures soar to around 5,000 degrees Fahrenheit. That is hot enough to break water molecules apart into hydrogen and oxygen. With JWST, astronomers used a technique called eclipse mapping. They watched as the planet moved behind its star. They measured tiny changes in the combined light at different wavelengths. By tracking those changes carefully, they reconstructed not just a flat map, but a three-dimensional structure of temperature and composition in the planet's atmosphere. What they found was dramatic. The hottest spot on the planet sits almost exactly under the star, near the substellar point. Around it is a cooler ring where temperatures drop enough that water should survive as vapor. Farther away toward the night side, the atmosphere cools further, but the winds do not seem to move heat efficiently from day to night. In the hottest region, JWST saw less water signature than expected. The best explanation is that the heat is literally ripping water apart. In cooler areas, water's fingerprint rises again. For the first time, we are not just saying, this planet is hot. We are watching the chemistry of that heat in 3 dimensions. That matters because the same method can be applied to less extreme worlds. If we can map the atmospheres of scorched hot Jupiters now, we can use refined versions of this technique to probe smaller, cooler planets later. One day, We might use descendants of this method to sketch out weather patterns on a truly Earth-like planet. Hot and cold zones, cloud belts, maybe even hints of an ocean or continent below. So in mid-November, while your newsfeed is full of human politics, JWST is quietly drawing 3D weather maps of a world where the sky is hot enough to destroy water itself. But not all worlds are bound neatly to their stars. Some wander, and one of those wanderers is doing something very weird. Astronomers have just announced a rogue planet called 0777601626 that is acting more like a young star than a planet. A rogue planet is a world that is not gravitationally bound to a star. It drifts through space on its own, glowing only faintly in infrared light, cooling and fading over time. Ka of 701626 is different. Using the European Southern Observatory's Very Large Telescope and JWST, astronomers watched it gulp down gas and dust at an incredible rate, roughly 6.6 billion tons. That behavior is something we normally associate with young stars. They undergo accretion bursts, sudden episodes where material from the surrounding disk falls inward, dumping mass and energy into the forming star. Seeing that same style of burst in a planet-sized object raises uncomfortable questions. What is Cha Onon 771626? Really a planet that was kicked out of its home system? Or is it more like a failed star, formed directly from the collapse of a gas cloud in deep space? Planets are usually defined by how they form, not just by their mass. If you can have objects in the gray zone that behave like stars while being closer to planet-sized, the boundary between star and planet gets fuzzy. In August 2025, the team saw the accretion rate jump by a factor of 8 in just a few months. The object brightened and changed, giving astronomers a front row seat to a growth spurt that may be teaching us something new about how all celestial bodies collect mass. And remember, this thing is not orbiting a sun. It is drifting through interstellar space, eating in the dark. If rogue worlds like this are common, the galaxy could be full of lonely quasi-stars, each carrying its own small envelope of gas and dust, evolving in isolation. Not planets in the way we think of them. Not stars either. Something in between. Speaking of strange visitors between the stars, we have another traveler in our neighborhood right now. The interstellar comet 3I. Atlas is swinging through the inner solar system, making its closest approach to the sun. It was discovered only a few months ago, in July 2025, by the Atlas survey. It is the third confirmed interstellar object we have seen after Oumuamua and comet Tuwi-Borisov. This one is big, fast, and old. It is the largest and likely the oldest interstellar visitor we have found so far. Right now, 3 Atlas is about 130 million miles from the sun. As solar radiation hits it, the ice in its nucleus sublimates. Gas and dust stream out to form tails. Telescopes on Earth have seen something odd. An anti-tail pointing toward the sun, alongside the more normal dust tail pointing away. At first glance, that might sound like science fiction. So, at first glance, that might sound like science fiction. One commentator even joked about alien technology. But the physics is almost certainly natural. An anti-tail can appear when our viewing angle lines up with the comet's orbital plane. Dust grains spread out along the orbit. From our perspective, that thin sheet of dust can look like a tail pointing the wrong way. More interesting than the tail is the chemistry. Observations from Chile and Spain show unusual composition, including nickel without the usual matching amount of iron and a strong carbon dioxide-rich gas cloud. JWST detected so too, at levels that suggest 3I Atlas formed in an extremely cold environment. Put all that together, and you get a rough biography. Billions of years ago, in a distant star system far from ours, a comet formed in a cold, far-out region, maybe in that system's equivalent of an Oort cloud. At some point, gravity kicked it free. It wandered the galaxy for eons as a frozen time capsule. Now, by chance, it is passing through our solar system, letting us sample chemistry from another sun's nursery. We cannot chase it with a spacecraft this time. We can only watch from afar, measure its light, and try to read the story in its spectrum. But even that is enough to remind us our solar system is not an isolated bubble. Material from other systems can and does wander through. The chemical building blocks out there are being mixed, swapped, and shared on galactic scales. Finally, we circle back to the telescope that keeps stealing the show, James Webb. Over the last 2 weeks, JWST has delivered 2 more results that hit the core themes of this channel: the chemistry of life and the origin of extreme objects in the early universe. In one study, astronomers used Webb to detect complex organic molecules around a young massive star in a galaxy beyond the Milky Way. These are not full biological molecules. They are building blocks, carbon-rich structures that can act as precursors to things like RNA and other key pieces of biochemistry. Finding them in another galaxy tells us that the chemistry that leads toward life is not unique to the Milky Way. It is written into the way carbon, hydrogen, oxygen, and nitrogen behave in gas and dust clouds under starlight and shock waves. In another result, Webb continues to stare at those strange compact objects in the early universe nicknamed little red dots. Some of them, like a source called Bird, appear to host black holes around 100 million times the mass of the Sun, already in place when the universe was very young. Their spectra are not like typical active galactic nuclei we see nearby. They seem dust-shrouded, still assembling, yet already blazing with energy. Together with the dark star ideas we explored in another episode, these little red dots are telling us that black holes in the early universe may have grown in stranger environments than we expected. So where does all of this leave us on November 17th, 2025? When you step outside tonight, you may catch a few Leonids carving quick white scars through the sky. In that same sky, invisible to your eyes, twin spacecraft are on their way to Mars to study the border between a planet's air and the void. Another satellite waits on pad to watch Earth's oceans rise millimeter by millimeter, far beyond the reach of rockets. An ultra-hot Jupiter is having its atmosphere sliced and mapped in 3 dimensions by a telescope 1 million miles from Earth. A runaway world is gorging on gas in a dark corner of space, challenging our categories of what a planet even is. An interstellar comet is dropping by with a chemical postcard from another sun. And the light from galaxies billions of years old is whispering stories about organic molecules and baby black holes to the honeycomb mirrors of James Webb. The universe does not care that it is 2025 on our calendars. It does not know that it is Monday, or that markets open tomorrow, or that your phone battery is low. But if you pause and look up, you can align your tiny slice of time with a much bigger clock. Meteor showers tied to a comet that will not reach a major outburst until the 2030s. A Mars mission that will only arrive years from now. Interstellar ice that has been traveling longer than our species has existed. Light that left its source before Earth formed, only now reaching our detectors. That is what we try to do here on Think Cosmos. Take the headlines of the week, stretch them out, connect them to the deeper story of how the universe builds planets, stirs atmospheres, and maybe, just maybe, creates the conditions for life and mind. So tonight, if you can, go outside, look for a Leonid or two. Picture escapade on its way to Mars. Picture WASP 18b roasting under its star. Picture a rogue planet eating in the dark. And remember that every one of those stories is happening in the same universe you are standing in. Thanks for watching Think Cosmos. If you want more deep dives like this, you know what to do. Until next time, keep your eyes on the sky and your mind on the cosmos.